Let's go ahead and go through an example and jump right into it. So normally there's a really painful memorization way and chart method of how to do this in a pre-calc class or an integrated 3 class or algebra 2. But we're going to go ahead and do the calculus method the way I teach my calc students, because that's actually a little bit easier. So what we're going to do with a polynomial, notice this is a polynomial, and we saw in the last video it's either going to be going up to infinity or down to negative infinity. That's how polynomials behave. Of course, you can enter this in Desmos and see what happens. But what we're going to do is we're going to look at the largest term here. So what has the greatest exponent here? Well, that's going to be the negative 9x to the 9. So we're really going to look at that. So if we want to figure out what our function's doing as x approaches positive infinity, I don't know why I was putting a negative there, but as we're approaching positive infinity, what we're going to do is we're going to plug in a large positive number. What would happen if you took negative 9 and you plugged in a large positive number? What would be the sign? So positive to the 9th, isn't that just still positive? And then negative 9 times a positive is going to be negative. So as x goes to positive infinity, p of x is going to negative infinity. Let's just put this in one color. And we'll do another color for the next part. Oop. Let's pick blue for the next one. So as x is, let's go ahead and do is x is going to negative infinity. So as x is going to negative infinity, same exact idea. We're going to figure out where is p of x going. So we're going to take a large negative number this time and plug that in. So if you could picture, we have negative 9 times a negative to the 9th, some large negative number. And so if you take negative number and raise it to the 9th power, it's going to be negative. So we have negative 9 times a negative, and a negative times a negative is positive. So that means that as x goes to negative infinity, our function, our polynomial, is going to be approaching positive infinity. And just so you know, I know there's other terms here, but the one with the highest power is going to ultimately dominate. And when you really talk about large numbers like infinity, if you take like 100,000 to the 9th, it's going to be way bigger than 100,000 to the 6th. So this is ultimately going to dominate the direction of our polynomial. So if you look at this one, it's still the same idea. So let's just go ahead, take a look at the positive case. So as x is approaching positive infinity, let's look at our greatest power here is 4x to the 8th. So if I were to think about that, if I were to have 4 times a positive number to the 8th, that would be 4 times a positive, which is just going to be positive. So this means that p of x will be approaching positive infinity. And then for x approaching negative infinity, 4 times a negative number to the 8th, well, we have an even power there. Negative times a negative 8 times is ultimately going to be positive because it's an even power. And that's just going to be a positive number as well. So p of x will be going to positive infinity. And then for the last one here, we have negative x to the 4th. So as x is approaching positive infinity, you can picture a negative positive number to the 4th is just going to be a negative times a positive, because we have the negative outside in the front. Some of us like to think it's inside the parentheses. It is not inside the parentheses on the outside. So you do the positive to the 4th first, which is positive, with the negative out front. So our p of x will be approaching negative infinity in that case. And let's go ahead and check as x goes to negative infinity. Same thing will happen. We have a negative to the 4th, which ultimately turns into a positive, and that turns into negative times a positive, which is negative infinity.